welcome back. So we have seen this type constructor list, which is parameterized by the type of the elements of the list. In fact, this is very relevant because a lot of functions of a list do not depend on the type of the elements. Indeed, if you look at the module list, it only contains polymorphic functions. So it means that the functions like length or reverse and so on are written once and for all. This is maximizing code reuse. We don't have to reprogram the length function of a list for each possible type of element of the list. So it saves us a lot of time and it increases our productivity. In fact, the programmer can define a own parameterized types, and that's the topic of this sequence. Here is an example of a parameterized type with only one parameter, and the value of this type represents a value which is optional. When you don't want to give the value of type alpha, you can use the constructor none, and when you want to provide this value, you can use the constructor sum. This type is very useful in programming, so it is predefined in OCaml. As you can see, you can apply sum, and the OCaml type checker is able to infer that as you apply it to 42, alpha is equal to int. But when you use none, in fact, this value is polymorphic. It has the type we want for alpha. Now here is another parameterized type, and this time it has two parameters, alpha and beta. And it represents a very common way to take the union of two arbitrary types. We have two data constructors. The first data constructor left represents a value of the first type, and the data constructor right represents a value of the second type. Imagine that you have defined a type for squares, for circles. Then you can join these two types into the type for shapes, which can be a square or a circle. If I want to generate a shape that is a square, I use left. And if I want to generate another shape, which is a circle, I use right. Here is another example. If we want to define a type for binary search trees, it will be parameterized by the type of the values that are put on each node of the tree. Again, we have two cases, the case for an empty tree and the case for a node, binary node in the binary tree. It is easy to implement the insert function. In fact, we already did it when we implemented the database based on the tree-like representation. But this time, there is no noise that was about how you deal with the contact of the database and so on. What we have here is a generic code that will work for any binary search tree. And there is no noise about the application which is to implement a database, we can focus on the implementation of the data structure binary search tree. And so we were able to implement the delete functions. I won't give the details about this implementation. And after that, we can reuse this implementation to define the type for databases as an instantiation of binary search trees where the type of the value on each node is a contact. The syntax to declare a parameterized type has the following form. You first write the type keyword, and then between parentheses and separated by commas, you write the type parameters that you want to introduce in your type definition. After that, as usual, you write the type identifier you want to introduce, an equal sign, and the type definition. The type variables quote A1, quote AN represent unknown types, which are the type parameters of your data structure. So they can appear in the definition of the type. Now, if you want to use a specific instantiation, a specific case of your parameterized type for some values of the type parameters, you just have to write between parentheses the value of the type you want to assign to each type parameters, separated by commas, and after that, the name of the type identifier of your parameterized type. Now, what kind of programming errors you can do when you use or define parameterized type? The first thing you can do is to not respect the arity of the type constructor. And also, you can, use unbound type variables in your definition. So imagine that we have a type parameterized by 2 parameters, like this one, and we instantiate it by passing 3 types to this type constructor. Then we get an error because, of course, the type constructor is expecting 2 arguments and not 3. So, of course, you have to be careful not to use type parameters, type variables that you don't have declared as a type parameter. So here, beta has not been declared, and of course, the type checker is unhappy.